Have you ever wondered why many programmers still learn the C programming language? Let's delve into that. In the vast and vibrant universe of programming, C is akin to a cornerstone, a foundation upon which many other languages are built. It's like the grandparent of the programming family tree. Now you might ask, why is that important? Well, understanding C provides a deeper comprehension of how computers work. It's often used in system programming, creating operating systems, and crafting compilers. Moreover, C is respected for its efficiency and control. It allows direct manipulation of hardware, which is ideal for tasks where performance is paramount. Plus, it's ubiquitous in the tech world, running on nearly every platform imaginable. So, while it may not be the newest or flashiest language, its relevance endures. It's like the trusty pocket knife of programming. Always useful, always reliable. So, we see that C remains a vital tool in a programmer's arsenal, even in our modern evolving world. Now, let's delve into the basics of C language. A typical C program is like a well-structured story. It begins with the inclusion of header files. These are akin to our story's prologue, setting up the stage with necessary tools and libraries. For example, the stoh header file allows usage of functions like printf and scanf. Following the headers, we have the main function, which is the heart of our program, the real story if you will. It's where the magic happens. This is where you instruct the computer to perform tasks. Every C program must have one main function. Let's illustrate this with a simple Hello World program. First, we include the standard input-output header file using #include stoh. This gives us access to the printf function. Next, we declare the main function with int main. The int before main indicates that the function will return an integer. The empty parentheses mean our main function doesn't need any input to run. Inside the main function, we write our code. For the Hello World program, we use the printf function to print our message to the console. So, we write print Hello World. The semicolon at the end is crucial. It's like a full stop in English, marking the end of a statement. Finally, we wrap up the main function by returning 0 using return 0. This signifies that our program has run successfully without any errors. So, our complete program looks like this. #include int main. Print Hello World, return 0. This is a simple hello program code snippet. C #include int main. Print Hello World, return 0. Take a moment to appreciate this simple program. It's your first step into the vast world of C programming. Remember, every complex program, every powerful software you see today started with such humble beginnings. With these basics, you can begin to explore the world of C programming. In any programming language, understanding variables and data types is indispensable. C is no different. To start, let's visualize a variable as a container, likely a box, that holds a value. This box can hold different sorts of data, hence the term data types. C encompasses several basic data types, namely int, char, float, and double. Let's delve a bit deeper. The int data type is designated for integers. These could be numbers without a decimal point like 3, 20, or -15. To declare an int, you would write int num equals $20. Take note though, that the size of an integer can vary depending on the system. Following, we have the char data type, used for defining single characters. These could be any printable character like A, Z, or to 5. An example of declaring a char would be char letter $Z. It's crucial to take into account that these characters are actually stored as integers, abiding by the ASCII standard. Progressing, we encounter the float and double data types. These are used for numbers with decimal points, like 3.14 or 2.718. To declare a float, you would write float pi = 3.14. The difference between the two lies in their precision. A float can typically handle 6 digits after the decimal, while a double can handle up to 15. To declare a double, you would write EE = 2.718. Now, you might query, why do we need different data types? Well, each data type serves a unique purpose and allows us to handle various kinds of data efficiently. For instance, if you're working with whole numbers, int would be your first choice data type. Conversely, if you're dealing with mathematical calculations that require high precision, Double might be your best selection. Also noteworthy is that C allows us to define our own data types using structures, unions, and enums. But that's a narrative for another day. Summing up, understanding variables and data types is like learning the alphabet before writing words and sentences. It's a foundational step in programming. Mastering variables and data types is a significant leap in becoming proficient in C. Control structures in C allow us to manipulate the flow of our programs. They're like the traffic signals of our code, directing the flow of execution to ensure that our programs run smoothly and effectively. Let's with the if statement. This is the simplest form of control structure. It's like a fork in the road. If a certain condition is true, the program takes one path. If not, it continues along the main road. For instance, if it's raining, you might decide to take an umbrella. In code, that could look something like this. CE if is raining, take umbrella. Next, we have the else statement. It works in tandem with if. If the condition for if is not met, then the else path is taken. Continuing with our rain example. If it's not raining, you might decide not to take an umbrella. That would look like see if is raining and take umbrella. Else, leave umbrella. Moving on to for and while. These are looping structures. For is used when we know exactly how many times we want to loop. C4 enter equals sign 0, I10, I++, print %d I. While, on the other hand, is used when we want to keep looping until a certain condition is met. C while is tired, read book. Lastly, we have the switch statement. This is like a multi-way junction. Based on a variable's value, the program takes different paths. It's a cleaner and more efficient way of coding multiple if and else statements. For instance, based on the day of the week, you might do different activities. That could look like C switch day, case Monday, work, break, case Sunday, rest, break. Control structures give us the flexibility to create more complex and dynamic programs. They're the tools that allow our programs to make decisions, repeat actions, and choose different paths based on different conditions. Functions in C are the building blocks of any C program. They are the subroutines or procedures that encapsulate a set of instructions to perform a specific task. For example, a print hello function could be designed to print the phrase hello on the screen whenever called. They are the fundamental units of work in C that bring our programs to life. Now, let's delve into how to declare and define a function in C. A function declaration informs the compiler about the function's name, return type, and parameters. For instance, consider the function add. The declaration might look something like this. Int add int a int b, where int is the return type, add is the function name, and int a int b are the parameters. A function definition, on the other hand, provides the actual body of the function. The definition of our add function might look like this. Int add int a int b, return a plus b. Here you see that the body of the function consists of the task that it performs. That is, adding the integers a and b. Functions play a pivotal role in structuring a program. They allow us to break down complex problems into smaller, manageable pieces, thereby promoting reusability and modularity. Suppose you need to find the sum of numbers multiple times in your code. Instead of writing the addition operation repeatedly, you can simply call the add function. This not only saves time, but also makes the code cleaner and easier to debug. Let's take a look at some commonly used functions. The printf function, for example, is used output data to the screen. Printf hello world will print the text hello world on your screen. The scanf function, on the other hand, is used to read input from the user. Scanf %d and number will read an integer input from the user and store it in the variable number. Functions such as strlen, *cp, strcat, and so on are used to manipulate strings. It's important to remember that C comes with a rich library of built-in functions, and knowing how to use them effectively can significantly boost your productivity as a programmer. For instance, using the strlen function, int len equals sign strlen s star, you can easily get the length of a string s star. In conclusion, functions are the heart and soul of C programming. They allow us to break our code into smaller, more manageable parts, making our programs more efficient and easier to understand. So the next time you sit down to write a C program, remember to make good use of functions. They can be your best friends on your coding journey. C programming, as we've seen, is a wide and deep field, but don't let that intimidate you. We've covered a lot today, brushing upon the key aspects of this robust language. From understanding the importance of learning C, which acts as a stepping stone to other programming languages, to getting a grip on the basics, we've navigated our way through the foundation. We then delved into the heart of C, discussing variables and data types, helping you understand how to store and manipulate data. Our journey continued as we explored control structures, the decision-making pillars of C programming. We concluded with an overview of functions, the reusable pieces of code that make our programming life easier. But remember, this is just the tip of the iceberg, and there's so much more to explore and learn. Remember, every expert was once a beginner. So start coding and explore the world of C programming. The journey may be challenging, but the rewards are worth it.